First of all, Apache Felix is an OSGI implementation, and I'd like to know who is actually familiar or heard of OSGI, just to get a little bit of a feeling. Okay, quite nice. Who has actually been using Eclipse at some point? That's even more nice, so a lot of you have a little bit of experience at least using OSGI. But I'll start out with a quick crash course of what OSGI is, just to give you a little bit of context about dynamic deployment. And after that, I'll talk about both deployment admin and resource processes, which are the main components of a dynamic deployment system in OSGI. So just to start out, a little bit of history. We have to go back to the last century, 1999, to see the birth of OSGI. When a couple of companies actually came together to think about a solution for home gateways. They were envisioning this home gateway being the central hub in everybody's home, controlling your fridge, controlling the lights and everything. And in order for that idea to work, there had to be some kind of managed framework where different parties could install and upgrade components without actually having to restart the whole system every time you do install something new or update something. Actually, that idea never became a big commercial success, but the framework that was developed for that was actually turned out to be useful for lots of other things. So even though the home gateway wasn't a big success, people found out other things to do with it, both in the embedded space, but also on the desktop and even on the servers. I mean, you have Eclipse using it as the plug-in system, and nowadays you even have things like the Spring framework and Glassfish using it as the basis for their application servers. So nowadays, if you look at the OSGI website, it's just explained as the dynamic module system for Java. Apache Felix is actually one of a couple of open source implementations. There are other ones out there, which is a good thing for any standard to have a little bit of competition. And actually, the nice thing about OSGI is that really as soon as you start using it, the framework itself, the implementation is not that relevant anymore. You develop your components and they'll run on any implementation. So if you look at the OSGI specification, there's two big books. The first is about the core specification, which explains all about the framework itself. And there's the second book, that's the service compendium, and we'll look into that a little bit more as we get to dynamic deployment. But first I want to go quickly through the framework and the different layers of the framework. And we'll start at the bottom at the execution environment. This actually defines a couple of profiles. Some of you might have been doing Java embedded or Java on the mobile phone, where you have these different profiles which basically define which subset of APIs are available. Well, this is actually the same thing. So you can have a very constrained profile that will run on an embedded device, or full-blown Java 6 desktop profile if you run on a system that supports that. And on top of that, there's actually the module layer, which is the first layer of the system. And the module, or bundle as it's called in OSGI, is basically the unit of deployment. Each bundle is just a jar file. It can contain Java packages, native code, other resources. And the only difference between a bundle and a normal jar file is that there's some extra metadata in the manifest. This metadata actually allows you to only share packages that you want to share. So for example, you don't want to share your implementation, only your interfaces. And you can simply say, well, I want to share or export this package, and you can do the other way around and say, I want to import this package from some other bundle. And the framework will then take care of the actual wiring. Nice thing of that is that you can also export specific versions of a package. So it's actually possible to have two different versions of a package run side by side in the same Java VM without the classes interfering with each other, which is a system that you cannot easily do without OSGI. Then you have to manually start messing with class loaders, and that's tricky. So on top of this module layer, there's a lifecycle layer. And every bundle, every component has its own lifecycle. That starts with installation. You can install a bundle, then it gets resolved, the imports and exports get wired, and then you can actually start and stop a bundle. And start and stop are actually two hooks that you have for starting your own code and stopping it again. At any point in this life cycle, you can also update a bundle. That means the current copy is stopped, a new copy is installed, and is run without actually affecting the rest of the bundles in the system. So there's actually a nice way to communicate, to do communication between bundles, and that's through what we call the service layer. There's a service registry, and each bundle can publish services there and can do lookups. And since this registry is highly dynamic, it's a little bit tricky sometimes because you actually have to keep track of what services are there. If they're still available, they can go away at any time, so that makes it a little bit harder to use. But it's a very nice and decoupled way for components to interact with each other. They only look up the service interface. They don't care about who actually implements it, so you can actually exchange implementations without the rest of the framework knowing it. So that's basically the OSGI framework itself. Now on to deployment. If you look at the specification and what it describes about deployment, it actually only specifies a couple of very generic roles. It says, well, you have this management agent, which is just a bundle that you install into your framework, and it is responsible for installing and updating components. It talks over the network to some provisioning server, which has some component repository where you can get new stuff from, and that's basically all that was defined about how to do deployment and how to provision components to a system. Actually, that was the situation until the last version of the specification, 4.1. There actually some new services were introduced that actually give you a little bit more help on how to do this. Because most people up to now were just installing individual bundles. So when you would do an update, you would just in a loop get all the new bundles, install them, and if something failed, well, maybe you had some rollback mechanism, maybe not. It was just praying that everything kept working. But since 4.1, there's a new specification called Deployment Admin, and that actually gives you a lot of help when doing deployment of updates or installing new stuff. It actually defines the notion of a deployment package. And a deployment package is basically just a version set of artifacts, bundles, and anything else you want to install. The deployment admin specification ensures that when you install or update such a package, the actual process is done in a transaction. So if the fifth update fails, everything gets rolled back nicely. That's a good thing. You can also provide what they call fix packages, which are sort of like a delta between two versions. So you can say, just give me, I have version 5 now and I want to go to version 7. Just give me the fix package for that. And then you get a package that only contains the delta between those two versions. You can actually sign these deployment packages to prevent tampering, make them more secure. And the nice thing is you can actually extend them through the use of resource processors. And I'll go into that a little bit more in a couple of minutes. So looking at deployment packages, they have a certain format that was designed so that they can easily be streamed. And this is done so that you can even install them without requiring too many resources on embedded constrained environments. So everything in the package is laid out in such a way that the whole installation process can be done by just processing a stream. So the stuff you need first is at the front of the package, manifest, which basically describes what's in there, then the signature files in case it's signed, and maybe some localization, then the actual bundles, the components that you want to install, and finally some other resources. And it's these resources that make it interesting, because that's actually a way of sort of extending what you install. Apart from bundles, you can basically add your own types of resources to these deployment packages, where every type of resource is identified by its MIME type, and every type of resource can have its own resource processor. A resource processor is mainly just another OSGI bundle that actually gets shipped alongside these resources, and it actually allows you to define some way of installing these resources on the target system. So that way, if you, for example, want to add some Debian packages or add some images or HTML pages that you want to somehow deploy on your target system, you can simply add a resource processor that knows how to deal with these resources on the target system. And that makes it a very extensible format. One of these resource processors is actually standardized in the form of configuration admin, which is a mechanism in OSGI to configure all kinds of different aspects of the framework, to configure services. But there are many other possible resource processors. Just a brief look at how this transactional mechanism works. It's not really rocket science. It's just like a two-phase commit, basically. So if you install a deployment package, you start at the beginning. Everybody gets a chance to initialize. And as soon as that works out, you go into a prepare phase. Again, everybody is asked if they can prepare their change. And if that works okay, then you get the actual commit. And then everybody should really commit what they've been doing. If anything anywhere goes wrong, you go into a rollback, and everything gets rolled back to its original state. And finally, this transaction ends. So, yeah, wrapping it up. Gave you a crash course of OSGI. I hope you learned a little bit about it. I explained a little bit about how deployment packages allow you to transactionally install and update components, and how you can extend this mechanism by using different resource processors. If you actually want a demo of some of this stuff, just come by and ask me. I have a nice demo on my laptop, or contact me after the conference. I think we actually have 1 or 2 minutes left, so if anybody has a question, go ahead. Yeah?
Is there any plan from Sun to add OSGI features in the Java runtime environment?
So the question is, are there any plans for Sun to add any of the OSGI features to the Java runtime? Actually, there are a couple of initiatives on that. There's JSR 277. The Java module system, and there are some people from the OSGI Alliance in that expert group cooperating with them, and there are some other JSRs out there. Basically, Java 7 is targeted for inclusion of this JSR, and they are working together. There's a little bit of tension, a little bit of politics involved, because IBM is a big sponsor of OSGI, and Sun doesn't really like that. So, but to be honest, over the last year, Sun has joined the OSGI Alliance again. They were a member when it all started out in 1999, and actually they've ported Glassfish to OSGI, and that's actually running on Felix now. And the main developer of Felix is actually now employed by Sun. So. I think they're pretty serious about cooperating with OSGI and including it in some way in the next Java version. And that would be a good thing, because there are some things that OSGI cannot solve without some cooperation with the virtual machine. So I think that's a good path forwards. Yeah. Yep. How does Felix compare to Equinox? Well, maybe I'm not the best person to ask because I'll say, well, Felix is great. But to be honest, Equinox is a framework which is very much targeted at the desktop and optimized for that. So it's a very good desktop system. Felix is a little bit more lightweight than Equinox, so it's more suited for embedded. That's it in a couple of seconds, but I can explain some more. Thank you.